We've all seen those science fiction films, haven't we? You know, the ones with crews on these epic journeys across space, journeys that take years, sometimes decades, heading off to distant stars, maybe new worlds. But then, if you actually stop and think about it, you hit this huge question, right? How on earth do humans survive voyages that long?
That's really the core issue of interstellar travel, isn't it? The very thing that makes space travel possible, all that emptiness, the incredible distances. That's also what makes it so incredibly tough for us humans. I mean, we're fragile,
Yeah.
and the sheer time involved throws up these massive biological, logistical hurdles that we're still trying to figure out.
And that's exactly what we're diving into today. We're going to explore some of the biggest roadblocks stopping us from, truly becoming an interstellar species. But crucially, we'll also look at some pretty surprising breakthroughs that might be bringing those sci-fi visions a bit closer to reality. Our deep dive today uses a really compelling audio source and a very detailed supporting article. Together, they give a fascinating look at where things stand right now. And we're going to kick things off with maybe one of the biggest challenges, getting humans into long-term hibernation, stasis, to basically sleep through those long, long journeys.
Yeah, for so long that just felt like pure sci-fi, didn't it? Human hibernation. The real problem has always been, okay, how do you keep a person alive, but in a slowed down state for maybe 5 years, 20 years? What about 1,000? It's not just about slowing down the body clock. It's about keeping people healthy, preventing everything from degrading over these, well, frankly, extreme lengths of time.
Okay, so this is where it gets really interesting. There's this company, SpaceWorks,
Yeah.
and their president, John A. Bradford, he actually believes they've cracked a key part of this long-distance travel puzzle. Get this. They were claiming they could have a working stasis chamber ready for space travel potentially as early as 2018. Now, that's a bold claim. Definitely makes you sit up and listen.
It really does. And their whole approach, it's actually grounded in something that already exists medically. It's called therapeutic hypothermia.
Mm,
What's really insightful here is that this isn't some brand new, untested idea from thin air. It's a technique hospitals already use in critical care, specifically for patients after, say, a cardiac arrest, or if they've had a really bad traumatic brain injury.
right. So what's the actual science there? How does cooling someone down, which sounds kind of counterintuitive, how does that actually help?
Well, the amazing thing is, it relies on a surprisingly small temperature drop. Our normal body temperature is about 37 degrees Celsius, right? 98.6 Fahrenheit. With this therapeutic hypothermia, they cool the body down just a bit to somewhere between 32 and 34 degrees Celsius.
Okay, just a few degrees.
Exactly.
Yeah.
But that small change, it has this profound effect. It significantly slows down your heart rate, your blood pressure. Basically, it drastically cuts the body's need for oxygen and energy.
Ah, okay. So in an emergency room, that little temperature drop suddenly buys the doctor's precious time.
Could be the difference between life and death, yeah. And you can immediately see how that might apply to a long space trip.
Precisely. Right now, medically, patients can be kept in this state for maybe 2 to 4 days, and studies show the technique works for up to 2 weeks without causing any, measurable harm.
2 weeks. Still a long way from years, though.
It is.
Yep.
But the source we looked at shares this incredible story. A Japanese man, he fell off a mountain ledge, apparently, and he survived for 24 days in a hypothermic state,
Yeah.
just naturally induced by the cold.
Wow, 24 days. Yeah. It's an extreme case, obviously, but it does offer this intriguing hint that maybe, just maybe, much longer periods could be possible under the right controlled conditions.
That's amazing, and that really highlights what SpaceWorks is aiming for, doesn't it? To stretch that safe stasis period from days or weeks to months, maybe even years. And Bradford, he claims the tech, the equipment needed, can be automated pretty easily, made space-ready. He talks to robotic arms, sophisticated monitoring systems for the passengers, tiny little transnasal tubes for the cooling, warning systems for when it's time to wake up. It sounds like something out of Alien, but based on real medicine?
It does. But, even if they nail the hibernation part, there's still this other massive issue that doesn't just vanish when you're asleep. Zero gravity. Even if your metabolism is slowed right down, being weightless for months or years, that's still a huge problem for the human body.
Right, the muscle loss, bone density.
Exactly. The source mentions SpaceWorks is looking into this. They're exploring things like electrical stimulation. It's something already used in physical therapy today. The idea is to use it to keep the crew's muscles toned, their bones strong, even while they're in hibernation, trying to counteract that wasting effect we see in astronauts, even on shorter missions.
Okay, so electrical stimulation to keep muscles firing even in stasis. That's clever.
Well,
But, like the source says, even if you solve hibernation, which is huge, it's still just one item on this massive laundry list of other problems for long-term space travel. The source actually mentions 11 more extremely great challenges. We can't possibly cover all 11 today, but we should definitely dig into some of the biggest ones.
Yeah, it makes you think, okay, beyond just keeping the humans alive inside the ship, what are the really basic barriers? Just getting the ship out there, moving it, navigating it, protecting it, and getting it back. It's not just about surviving the time, it's about managing the journey itself across these, well, unimaginable distances.
And one of the first hurdles, even before you properly leave Earth, is just the incredible cost, escaping Earth's gravity. The source gives a really stark number, nearly $200 million just to launch the Mars Curiosity rover.
Just the rover, no people.
Exactly. Now, picture adding people and everything they need to survive for years. Food, water, air, life support, radiation shielding, medical gear. That payload becomes absolutely massive, which means way more fuel, which means costs just go through the roof. The real insight there is how the survival aspect itself becomes maybe the most expensive part of the whole mission.
And even if you could afford it, our current rockets are just, well, they're painfully slow for interstellar distances.
Right.
Chemical rockets give you a big kick to get going, sure, but they burn out in minutes.
Right.
After that initial boost, you're basically just coasting. Getting to Jupiter, even within our own solar system, could take 7 or 8 years at current speeds.
7 or 8 years just to Jupiter.
Yeah. So for any serious interstellar trip reaching another star, we need something completely different for propulsion. A radical turn, as the source puts it. People talk about speculative stuff, like an M drive or even warp drive. But the basic point is we need a totally new way to get sustained speed over cosmic timescales.
Okay, so cost and speed are huge. Then there's this other thing, the space debris minefield. Turns out, space isn't quite as empty as we think. It's full of dangerous junk, not just asteroids and meteoroids, but our own trash.
Yep. Spent rocket stages, dead satellites, even tiny flakes of paint from old missions.
The U.S. Space Surveillance Network, they track about 17,000 objects that are at least softball-sized. And these things are whipping around Earth at something like 17,000 miles per hour.
Just think about that speed.
And that's only the big stuff they can track. If you count the smaller bits, the source estimates maybe 500,000 objects orbiting Earth right now.
500,000.
So any ship trying to leave the solar system, let alone travel between stars, would need some kind of shield. Something to deflect potentially millions of these tiny high-speed projectiles that can just obliterate the whole ship.
It really drives home that even a tiny fleck of paint moving at orbital velocity has incredible destructive energy. Space is like a minefield where microscopic things can kill you.
Sounds terrifying. An invisible gauntlet you have to run. And speaking of invisible problems, how do you even navigate out there? You can't just use GPS once you leave Earth orbit.
Right. No Google Maps in deep space.
Our current best bet is something called the Deep Space Network. It's basically these huge antenna arrays. There are sites in California, Australia, and Spain.
Yeah, the DSN is our cosmic phone line, essentially. It works by timing radio signals. How long does it take for a signal to travel from an antenna to the spacecraft and back again? That round-trip time tells controllers the spacecraft's distance and allows them to calculate its position.
Yeah.
But the further away the spacecraft gets, the longer the signal delay, and the less precise that positioning becomes.
Ah, I see.
So imagine trying to navigate to another star system using a method that gets fuzzier and fuzzier the further you travel. It really highlights the challenge of just knowing where you are over those immense distances.
And let's say you solve speed, cost, debris, navigation. You still have that fundamental body turns to mush problem. The awful effects of long-term zero gravity we mentioned earlier. Our bodies just aren't built for it, are they? No matter how much you exercise on the space station treadmill.
No, the effects are just devastating over long periods. Immune systems weaken. Red blood cells can actually burst. Astronauts are prone to kidney stones. The heart works differently under stress. Our whole biology evolved with Earth's gravity as a constant. Take that away for years, things start to break down at a really basic level.
And then on top of all that, you leave Earth's protective magnetic field and atmosphere, and you run into what the source calls the microwave effect. Space radiation. You're getting blasted by these subatomic particles, cosmic rays traveling at nearly the speed of light.
Yeah, it's nasty stuff. This radiation can basically cook your cells, damage DNA, significantly increase cancer risk.
And it gets worse.
It does, unfortunately. There's something called secondary radiation. When these high-energy space particles smash into the aluminum hull of the spacecraft, the very thing meant to protect the crew, they can cause the aluminum atom's nuclei to basically shatter. And that explosion releases even more high-speed particles inside the ship.
Oh, great. So the shield makes it worse.
In a way, yeah. It compounds the problem. That's why the source uses that analogy, almost like sitting in a microwave. It suggests that simple shielding might not be enough. We might need totally new materials or maybe even act like force fields or something.
Wow. It's mind-boggling when you lay out all these hurdles side by side. And we've only really touched on a handful of those 11 extremely great challenges mentioned in the source. It makes you realize just how massive an undertaking long-distance human space travel really is. But despite all that, there's still this feeling, this optimism, that humanity is actually making progress, that we're solving these things, or we're close.
Well, what's really interesting is how progress in one area seems like it could ripple through the others. You look at the work SpaceWorks is doing on hibernation, for example. If they
Hmm.
crack that, maybe it makes solving some other problems easier or changes how we approach them. It hints that maybe these challenges aren't isolated.
Hmm.
Maybe as we solve one, the others start to, fall like dominoes as we apply that ingenuity. We've seen that pattern before in science.
Right. And then the source material leaves us with this really provocative idea, something to really chew on. It floats the possibility, and I want to stress this is presented in the source purely as a viewpoint, not something we're endorsing. But it raises the idea that given all the unexplained aerial phenomena, the strange craft people report seeing, maybe there's a very big possibility that many of these complex space travel problems, they might have already been solved years ago.
Mhm.
The source even speculates, again, purely speculatively, that maybe this was done through back-engineered alien craft.
Which, purely as a thought experiment based on the source's perspective, it certainly raises a big question for critical thinking, doesn't it?
Yeah.
What other solutions, what other approaches might actually exist or might have existed in the past that aren't part of the public discussion right now? It kind of encourages you to keep an open mind about the full range of possibilities, even the really extraordinary ones, when considering these huge technological leaps.
Right.
Questioning assumptions.
It really is astounding when you step back. The sheer scale of space, these incredible challenges we've just talked about, getting there, surviving, but also that relentless human drive to figure things out, to overcome, which you see in these breakthroughs like hibernation research, it really makes you wonder, doesn't it? Given the progress on something like stasis, what other seemingly impossible barriers are we maybe just about to break through? And how could solving these problems completely change how we see ourselves, our place in the universe? What stands out to you listening to this as the most surprising challenge or maybe the most exciting breakthrough we touched on today?